Hello everyone. Today I am discussing about the history, a brief history of optical fibers towards its evolutions to the current technologies. So all of we know that optical fiber relies on the total theory of the total internal reflections, which is shown here in this figure. And these total internal reflections will give the main philosophy of the optical fiber of guiding the light. So we know that it depends on that the conditions of the Snell's law, which is the light should fall here on higher than the critical angle, and another thing is that the light should launch in the high refractive index material. So with that concept, that Caladon and Babington, they showed this phenomena and guiding that proving that the light can guide through a stream of water. The same experiment, it was shown in Royal Society in 1917 by John Tyndall, and then people tried to make it implement for the technological purpose in the very early 19th century. This optical fiber are used made with simple glass, which is mainly used for the image transmissions, and it is used for the medical purpose like for endoscopies applications and all these things. But never people at that time people never thought that it can be used as a communication purpose. Then the main problem of that previous glass tube or the stained glass fibers, it was the very high due to the very higher refractive index, so the bending loss was very high on this type of fiber. To avoid this problem, our Indian physicist in 1952, he proposed the concept of the core and cladding, and he proposed that the same glass material which can be varying refractive index from core to cladding by changing the doping concentrations or doping material itself. So with these concepts, he proposed with the same strain of the glass can be made with core and cladding, and we can cover it with a jacket, plastic jacket, so that it can be used for many rugged purpose. After that, by invention of the laser, people start to think that light can be, this optical fiber can be used for the communications. So but main challenge of the time for using this optical fiber, it is having very loss high. That time people decided if the fiber comes with 20 dB per kilometer loss, then it can be used for a practical item for a communication purpose. So then to solve this problem, Charles Cow and his group started to do research, and many people started also, but he find out the exact cause of the glass impurities, which is the oxide ions, and these OH ions are the main culprit to make the loss in the optical fiber. That one he proved, and he suggests a method to purify the glass, and how to get the purified glass or suitable glass which perform very low loss if it is made for the optical fiber. So it is his paper, and due to these inventions and rather contributions of the optical fiber for the communications, it gives him Nobel Prize in 2009. So now we can see back that how it is evolved. So in 1972, with this idea of proposed by the Charles Cow, Corning Glass Company of United States fabricated first optical fiber by titanium doped on silica. So these fibers, and at the same time it was invented that gallium arsenide semiconductor, which gives the emissions around 0.8 micrometer or 800 nanometer. So this can be used for the telecommunication purpose. So in 1977, actually the General Telephones and Electronics of USA seen the first live telephonic traffic through the optical fiber in in a Long Beach of California. So it was implemented, and that time the used wavelength was 800 nanometer, and this wavelength is called the first generation wavelength. So major performance of the concern of this optical fiber communication was that bandwidth, attenuations, and dispersions. So after that, scientists found that optical fiber shows the zero dispersion wavelength at 1.3 around or 1330 nanometer, So in that range, people find also a suitable laser with having Indian gallium arsenide diode laser, and by this way it comes down, the loss comes down quite low, around 4 dB per kilometer. So we need a repeaters of 50 after 50 kilometers, and also the bit rate goes quite high, 1.7 GB per seconds. So this is called the second generations, that is the 1.3 micrometer is the second generations communication wavelength. After that, the third generation communication wavelength means where in which domains still we are using this wavelength 1.55, because this wavelength has the minimum attenuations loss of the optical fiber. At the same time, indium gallium arsenide phosphate semiconductor lasers are used, that is very conventional now for this source of these things. At the same time, David Pine and his group invented the hardware doped fiber amplifier, which is very useful as repeater in the optical fiber communications. So these things, if we see converge all these things, again we can see the in this figure. So then we can see the attenuation is very high here in the fast communications window, whereas if we go back, there the loss pictures, that red lines, it gives the loss pictures, which is but rather purifications of the silica material, it comes very low here, around 1550 nanometer, and this is called the third generations or the third generation window of the optical fiber, where we are still working. Thank you.